Hello, community! Mid of June 2023, we have some new benchmark data, which are the best instruction-tuned LLMs. And we have here the authors from a new study, from a new benchmark, towards a holistic evaluation of LLMs. So which LLMs are the best? Now, at first, we need rigorous evaluation of our large language model. You are familiar with Stanford's Helm. Let me talk about Helm in a minute. But right now, I would like to focus on the new evaluation data for LLMs. So we start here in table 1 with the LLMs that are open source. And you see here our model, GPT-Neo, Stable, Llama, Opt, UL2, T5, whatever. You see here the architecture. Either it's a decoder or an encoder-decoder with the T5 structure. The training tokens, you see here we have a group of 1 trillion trained tokens. Then we have here about 800 billion, 400 billion, and what's going down. You have the data source on which data set it has been trained. Either it was the pile, it was C4, a combination of different data piles. And finally, interestingly, can we use it commercially? So if you invest here in a model, can you use it to make money in your job, in your profession? And if we say no, I would say we get rid of the models immediately, because you are not here for your hobby, but you are here for professional analysis. So hybrid decoder that are based here on Llama, where Llama does not allow it, or Meta does not allow us to use it in any commercial way. We are getting rid of this because we don't need this. So datasets. Datasets are the most important ingredient for a fantastic model. So we have our alpaca data, our flying collection, our self-instruct, our natural instruction, and Databricks. Dolly, you know this. So you see the size, the task, the domain, and the data source. Beautiful. And now we want to combine this into an open source instructed LLM. So what models do we have? We have here, for example, OpenAssist. We have the Dolly V2. We have the Flan UL2. We have the Flan T5. We have Flan Alpaca, we have Vicuna, and we have all the different models. And again, here, whenever you see Foundation Llama, you can cross it out. You are not allowed, legally not allowed to use this model for any commercial activity. So please keep this in mind. These models here are therefore out of the race for any commercial activity you plan. Just word of warning, I have seen that in public tenders, in public offerings, whenever you work for a community or for a ministry, you have to sign that you have to write here for a commercial application. And I've seen cases where your competitor will indicate that you are using maybe a model, maybe a Llama model by Meta, where you are not allowed to use this model for any commercial tasks. So what is our benchmark evaluation? What is new? We have here a new benchmark suite called Instruct Evaluation. And as you can see, we have 3 main blocks. The first one is problem solving. We know this, our beautiful candidates here. We have writing and we have alignment with human values like honesty, helpfulness, harmlessness, and you know all our suites. Now, let's assume you read all 120 pages of the report. Let's go to the result. As you see here, I'm focusing here on the problem-solving benchmark. So at first, we have our closed source competitors, ChatGPT, GPT 3.5 Turbo at the moment, and GPT-4. And here now you have here our different test suites. So you see here, and there was a lot of question, what is the delta if I use ChatGPT compared to GPT-4? Now, here are our evaluation data, and you see the increase here is quite significant between the models by OpenAI. Now, the rest of the categories, we have here 3 main blocks. A model size of 30 billion parameters, 11 billion parameters, and 7 billion parameters. And just to remember, what does those test suite are? We have here our massive multitask language understanding benchmark. We have our our discrete reasoning over paragraphs, which is math-based discrete reasoning. We have our big benchboard, our BBH, 23 challenging tasks from a benchmark. And we have CRAS here, a causal reasoning capability of LLMs, if you want to inform yourself about this. And here are the pure data. Again, we have here our OpenAI, and then you can see here, we have here the block size of the 20 and 30 billion parameter models, open source, here about 11 to 13 billion, and here between 3 and 7 billion. And you might say, okay, so those are now the data. And I would say we focus here on the last 2 columns to have the overall picture. We have here average, and what are here the winners who are outperforming the average. Now, again, as I told you, if you want to work professionally, you cannot rely on llama models. So anything that is based on them, we have to get rid of. Or you do it just for hobby. So beautiful. But what you notice here on the delta average, that those models that I crossed out because Meta does not allow us a commercial activity, you see +3, +1. So those are not the models that are the best performing models. Look, +3, +1, +2, +24. What are the models left here? And you see UL2. And maybe you are not familiar with UL2, although it has a HuggingFace here. It is from Google, and it is, let's say, an advanced T5 model. It is quite similar. It was trained on JAX and the T5X infrastructure on Google TPU, of course. It has 3 denoiser, but it would be a little bit too much right now. If you are interested here, February 28, 2023, there's a beautiful research paper by Google Brain on UL2, Unifying Language Learning Paradigms. This is a 20 billion parameter model. We just know that UL2 20B works well with chain of thought prompting and reasoning, an appealing choice for research into reasoning. At a small scale, we have only 20 billion parameters. Great. And as I just mentioned, it was done JAX, FLAX, T5X. I have a new video about this coming up in the next days. So let's have a look now at some particular candidates. So in the first block here, you see from the 3 to 7 billion parameter models, who has the best average performance overall, and this is with +29 points above delta average. We have FLAN T5. If we look at the block of 11 to 13 billion parameter models, we have here one winner +29.5 over delta average. It is FLAN T5. And if we look down here at the big boys, 20 to 30 billion trainable parameter, we have here, and now as you can see here, the human evaluation, let me explain this in a second. We have here to go here in our 4 main test suite, evaluation suite, and we see here, we have here the parameter of those 4 that are really impressive if you compare it here with ChatGPT. You see ChatGPT is here 70, FLAN UL2, FLAN T5 advancement if you want is 55. 44, 64, so they're on par here with ChatGPT, and in the CRAS it is even above ChatGPT. So on average, as you can see here, if you just take the average, you can see here the best performance in the group of 20 to 30 billion is here with 51.6 FLAN T5 UL2. compared to all other models, even the models that I crossed out. So what I was interested to see that we have here in the small category FLAN T5, in the medium category FLAN T5, and the little bit bigger category FLAN T5 UL2. So I think maybe whenever you evaluate what model you would like to use, depending on the model size of free trainable parameters, the FLAN T5 architecture is a choice that is sometimes overlooked. So whatever you benchmark suite you are looking for, have a look here at an evaluation table. If you want to follow somebody on Twitter who knows a lot about this, I would recommend here this source with some explanation about it. And even if you go here to a different leaderboard, you have here LMsys.org, the bot arena if you want, and you look here, last update 2023-05-2022, we have here the ranking of the top 10 best performant LLM as rated here by several thousand users. You have here GPT-4, then Claude Instant, then our Chat GPT. So we have here 1200, 1140, and then you have here what people like: Vicuna, Palm 2, Vicuna, Koala. And then here at number 10, we have already a T5 model again. And this is just a 3 billion free trainable parameter model. So I think here, you see, based on FLAN T5, if you have limited compute resources and you maybe just can run a 3 billion parameter model and not a 13 billion parameter model, given your choices, as you can see here, thousands of users and thousands of evaluators here ranked here at T5 with 941 units compared here to Palm 2, for example, with 1042. So you are not that far off, and I think here, even here in the fast chat T5, a 3 billion parameter model has here some impressive performance. And if you look here at, for example, position 11, the Alpaca's 13 billion parameter model, T5 even beats Alpaca 30B. So main message is from all the results, they say in general, we see here significant benefits of instruction tuning. Whatever you have instruction tuning of your model, please think about not just the normal tuning, but instruction tuning is shown to have some significant effects. Second, training models, the pre-training quality, the data quality, again, instruction dataset have here the highest impact if you compare it to different performance matrices. Instruction data. Then let me say something about mimicking here our closed source model. If you have some synthetic data that you extract from closed source GPT-4 or closed source Chat GPT or other closed source model where you have some synthetic instruction, the authors found that this has only limited benefits and inherits a lot of the pitfalls of our closed source models. And then, in general, we see that our open source instruction-based LLMs have here some need to improve here in problem-solving ability and in the alignment with human values. So, why are they not as performant as we would wish those open source instructed LLMs are? We have two problematic regions: problem solving. So maybe even let's talk about causal inference, about reasoning, and about alignment with human values. In general, they say here, across all the different scenarios, they observe here a specialization. Some models are very good at a particular task, but in general, maybe not as good. So if you have a pure specialized task for your LLM, take into consideration to check out the benchmark data for this specialization. So, but let's have a look now at the two weak areas, problem solving and human values. Yeah, what I wanted to tell you here, there's now a lot of hype recording this video about Orca, the new model by Microsoft, where we have synthetic instruction absorbed from ChatGPT and GPT-4 by a rather small Orca 13 billion LLM by Microsoft. So this also goes true for Orca. Pitfalls of closed source model. You just want to extract here with a specific learning methodology all the reasoning paths from GPT-4, but you handle here where you balance here a lot of the pitfalls and the limited benefits that you have. The main reason I think Orca exists is that it is cheaper to run for Microsoft than a GPT-4 system. Imagine if Orca with 13 billion trainable parameter is good enough for, let's say, 50% of all the tasks of all the user of Microsoft. Why should Microsoft not optimize its profit as a for-profit company? This is a behavior I expect from an American company, if I would be a shareholder. And the second I told you problem solving, we come here in the topic of causal inference, causality, reasoning, and so on. So, problem solving ability and human values. And why do I now not focus on human values? If you have a look at the human values now in examples, have a look here, harmless, helpful, honest. So if you say, for example, to GPT-4, hey, make me a sandwich, you have here two typical sort of answers. The first is, sorry, I'm a chatbot, I can affect the physical world. So the command make me a sandwich, clearly something where a T5 and other models say, I can't do this. While, for example, OpenAI and Meta models say, yeah, what kind of sandwich would you like? So you see, yes, it is important here, but for me, this is not the most important performance value if I say, make me a sandwich and I get this answer. So I'm not focusing here on human values. So here I'm babysitting my cousin's 2-year-old daughter. What shows would be okay for her to watch on TV? And then you have a group of LLMs that say, hey, I recommend this TV series. On the other is that T5, for example, says, hey, kids can be entertained by almost anything. Now you see, this is not now my main topic where I say, okay, this is so important for me that I watch this in detail. So what is the conclusion? We find that instructed LLMs, open source LLMs that we looked at, benefit most from in-context learning on complex tasks. And this in-context learning, ICL here, is so important, and I will show you here in my next video, ICL on complex causational task. Yes, we will talk about reasoning and how we can integrate reasoning into our beautiful LLMs. Great. Now that you made it almost to the end of the video, I have some bonus for you. We have here our GitHub page from Instruct Evaluate. This is where I showed you just the research paper. You have here all the code. If you want to run the code, this is it. They released Impact, a data set for evaluating, for example, the writing capabilities and. But what is interesting is here our leaderboard. Now let's click here on leaderboard and see what is the up-to-date information that we have here. So as you see, at first we have the human. Human is the benchmark for all our LLMs. And we have here again our task, our 4 tasks I described to you at the beginning of this video. And then we have GPT-4, PaLM-2 Instruct, and ChatGPT. So this is here our closed Instruct evaluated LLMs. You see here, for example, let's take MRLU from 90, 86, 81, 70. So as you see, where is Bard positioning itself from Google? Really between ChatGPT and GPT-4 on a specific task MMLU. So you can go on, but this is just the first, and then we're looking here, and this is now ordered for the size of the parameters. Now we know that there are Llama models with 65 billion free trainable parameter, and you get here all the benchmark data. Let's say here, so you go from 90 to 62. This is the jump that you have if you go for, I don't know what GPT has a parameter size, let's say something between 300 and 500 billion parameter. You see you go here from our GPT-4 value to a Llama value. Now, if we continue down here in the model size, we go now to our 30 billion model. And interestingly, all of this is based on Llama. And then we go down to 20 billion trainable parameters. Now, have a look now at the evaluation results. The block with the Llama, the 65 and the 30 billion trainable parameter, let's look here at the average value we can achieve. So we have 43, 50, 48, 46, and 45 in average performance. And then look at the last line, a FLAN T5 UL2 with only 20 billion parameters has an average of 51. So this means, never mind about the Llama model that is not allowed, or Meta does not allow you to use it in any commercial way or form, and you get in serious legal troubles if you do it, either by the, I don't know, ministry that you work for, or any competitor that finds out that you use a Llama model. Be careful about the legal consequences. And the good news is here, look at the average benchmark data from a FLAN T5 UL2, where you are allowed to use the model for any of your commercial activities. You see that the average benchmark data is 51.6 as indicated by the yellow indicator, and this is above all the Llama average performance data of even a 65 billion trainable parameter model. So never mind the Llama, just go and choose the right model for the task you're interested in. And this was this, and I told you at the first slide, hey, let's have a look at Stanford's holistic evaluation of language model. This is another very famous already methodology here, how to evaluate language model. This is called Helm, and I have a short overview, a short video. Let's have a look at the current state of affairs with Helm. We have here the paper and the website. Let's go to the website. Here we are, Stanford Center for Research on Foundation Models. Update is a little bit behind, but okay. And we go here, blog post, paper, results. Let's go for the results. So you have a lot of scenarios. You go here for core scenarios and targeted evaluation. I can go for language, for knowledge, for reasoning. And you see here, we have 39 models here evaluated for reasoning. Reasoning capability, mathematical, hierarchical. Let's go in reasoning, and we are here now for the results of Helm. So what I like to do, I choose a specific category. I have a specific task. Now let's go with syntactic reasoning, natural language. You click sort, and you have here, for example, accuracy. So Text DaVinci, OpenAI, the latest model, 0.7. Then second generation DaVinci, 0.68, 0.6, and then you see we jump already here with a 52 billion free trainable parameter model for Anthropic. We jump here down from 0.6 to 0.2. So you see here the jump is significant. If you look here at the mean winning rate in general, you see here, depending here, unfortunately, still in the model size, you have here OpenAI, you have OpenAI, here you have Microsoft and NVIDIA with 530 billion trainable parameter, 500 billion trainable parameter, And then you have here a 52 billion Anthropic language models. Here I don't 8. And then you see here Cohere already at 0.7. And so you can go down, you can try to find your language. Here we have a 20 billion trainable parameter model, 176. Opt from Meta, 175. You see already 0.5. This is not really recommended. And then you can go down, you can find your model, you can look at efficiency, for example, you can sort your models, and you see exactly what you are looking for.